All right, so we'll begin with the discussion of zones and subzones here. So in this discussion, zone is uh, a comparison to other technologies or some voice-related capabilities. One example is like routing protocols where neighborship is formed. So neighbors, for example, in OSPF or EIGRP, or relationship itself, which will be something like registration of the phones here. So that is what zones is about. So zones is a collection of the endpoints. So you will find the term zones and subzones. We will see a clarification of that here, the differences and everything. So zone is a collection of endpoints. And then they are subdivided into different uh, groups for different purposes that we will see here. What are the different types of zones and subzones? We have local zone. Local zone is the component of expressway. You can say that an expressway itself is a local zone, and a local zone is an expressway. All the devices are the part of local zone, whether they are registered to it or to expressway or not. All the devices are part of local zone. So local zone is the expressway itself and is default created, and it is always there. You cannot change or delete it. And it is important to understand for devices which are inside your organization. So every part of the expressway is a local zone, and all the devices are part of a local zone. Then local zone is further broken into other zones, which are called subzones, which we will talk about in more detail here. So, for example, we have talked about local zone. Then we have neighbor zone. This is another zone which connects the expressway with other parts of the network. For example, another CUCM or another expressway in any other branch or other locations. Yeah, so that is one example. We will see that again. Expressway to expressway C, for example, in two different locations. So a neighbor zone will be created between those. Then the local zone can be further divided into subzones, which are again a logical grouping. In subzones, we have various other types of subzones. For example, in subzones, we have default subzone. Now, just not to confuse, we have a default zone also. Now, default zone and default subzone are different. Default zone is something which connects the expressway with anything outside of the network. Whereas default subzone is the part of local zone, and all the endpoints gets registered to this default subzone. So all SIP HT23 endpoints gets registered to this. Yeah. So this is for all the registration here. So all the registered devices on that expressway would be the part of default subzone, which is automatically created. Then a default zone, as we discussed, is a zone which connects the expressway out of the network. Then we have another subzone called traversal subzone. We have two traversal subzones, one for expressway C and one in expressway E, which are client and server. In expressway C, we have traversal client, and on expressway edge, we have traversal server. So traversal subzones are used to handle the traversal calls, which are for firewall traversal, or even the type of calls which are interworked, like we discussed, HT23 to SIP traversal or IPv4 to IPv6 traversal. These are all the part of traversal subzone. So they have to go through the traversal subzone. Also, there is one more special type of traversal call, which is called dual NAIC, which is only configured on expressway edge. Yeah. So write it here. So in the traversal zone, or it's a traversal subzone, we have the handling of the traversal calls, and the traversal calls are of these four types. First is firewall traversal. Second would be HT23 to SIP traversal. Then IPv4 to IPv6 traversal. So that simply means that these devices, these endpoints which are registered on the expressway will be the part of the default subzone, and for the communication between these, it has to go via the traversal subzone because that's a traversal call. And these two are also called interworked calls. So for that, as per the configuration, we need to have interworking enabled, and as we enable interworking, a traversal subzone is created. Yeah. Then we have the fourth type of traversal call, that is dual NIC. This is configured only on expressway edge, yeah, to traverse the DMZ. So which is the part of traversal server, and this is for expressway C, and this is traversal client. Okay, so we have various different types of the zones and subzones. Let me begin and then we'll get into more details. So subzones and zones, we can see here what they are used for. Subzones are basically used for bandwidth management and for access control, whereas zones are used for routing to different parts of the network. So here we can see some examples of subzones, and we have some zones. We have traversal subzone, default subzone. We have default zone, which connects the expressway with the other part of the network, and it resides on the edge of the expressway. So let me just explain it with a small diagram here. So let's suppose we have this expressway C. So it has a local zone. Within the local zone, we would have a default subzone. All the endpoints, all your SIP, SE23 endpoints will get registered to the default subzone, will be part of default subzone. Then we have a default zone. I would create it like this, as this is on an edge, and it connects the expressway to the outside of the network. Then we have a traversal subzone for all the traversal calls as we discussed. Yeah. So default zone for all the endpoints registration, default zone to connect out of the expressway, traversal subzone to handle the traversal calls. Then there is something called default links. Now, what are default links? Default links are the logical connections between the subzones or between the zones and the subzones. So there are three default links which are automatically created if you have these zones and subzones. So the first one is from the default subzone to default zone. Like this. So there will be this logical connection between them for making the connectivity, the routing between all these different types of calls. Then the second is default subzone to traversal subzone. These are called links. The default subzone to traversal subzone. Then third is traversal subzone to default zone. These are all automatically created with these zones and subzone types. So that is the main types of zones, and then we can create manually as well some subzones if we want to. That is basically done for any bandwidth management if we want to do, or we want to divide the groups of endpoints, and for performing some routing based on bandwidth management, that we can do here. So expressway use zones as a placeholder for different endpoints, neighbors, destinations, and a zone is a collection of endpoints, either all registered to a single system or located in a certain way, such as telephone number mapping or DNS lookup. So there are some standards like E.164 standards which are used for which we can create a separate zone manually just for the E.164 numbers or for URI format or IP address, and where we need a DNS lookup so we can create DNS zones as well. So we will talk about that here. So let's begin here. Okay. So in the zones, we have talked about these different types of zones. We can see here we have local zone, we have a traversal subzone, then we have a cluster subzone as well. This subzone is created when two or more expressways are clustered together. So whenever you have a cluster of expressway, so a cluster subzone is also configured automatically. So firstly, local zone, which is the collection of all devices registered to expressway. The local zone is divided into those subzones, and these subzones include the automatically created, and we can create some manual subzones as well. So for subzones, there's a limit of how many subzones we can create it per expressway. That is 1,000 we can create. Okay, so in addition to this, the two special type of subzones are these traversal subzone and cluster subzone, where the traversal subzone is used for the traversal calls. Its purpose is to manage bandwidth, control bandwidth that is used by the traversal calls. So we can provide the configuration where we can choose the amount of bandwidth required for each type of traversal call. Uh, that we discussed, the different types, so we can assign different amount of bandwidth. Then cluster subzone is created when expressways are clustered together. So any calls between the two peers in the cluster will traverse this subzone during the call setup. And it cannot include any registered endpoints. Only this is for the purpose of clustering. Then we have neighbor zone, we have traversal client, traversal server, we have a DNS zone, we have unified communications traversal. So neighbor zone is a connection to the neighbor system of the local expressway. Neighbors can be a part of your own enterprise, for example, with the CUCM or another expressway node or part of a separate network or even a standalone system like the third party device. Traversal client is used when the expressway connects through a firewall to another expressway. And traversal server is when the expressway wants to connect to the expressway through a firewall. So it's just traversal client is configured on the expressway C and traversal server on expressway E. Then we have DNS zone, which contains the endpoints that are discoverable by the DNS lookup. So for that, we have DNS zone. Then we have a unified communications traversal zone, which is either a traversal client or server that is used for features like mobile and remote access. So this is the structure of local zone as we just discussed, as I showed you. So we have expressway with a permanent zone called local zone, which is referred to the expressway itself. And the devices that are registered to expressway are identified as registered to the local zone. And a default subzone automatically gets created just to segregate it for the devices which are registered directly on the expressway. So if you're searching for a device on a network, then search the local zone of each expressway to locate it. The local zone cannot be created, deleted, or modified. But you can divide it into different subzones. So it exists permanently, and as a default process, the expressway always search the local zone first whenever it tries to locate a device. So here we can see we have a local zone which contains subzones with other zones around the edge, which are zones like default zone, and these are the subzones. That is the difference here. Then we have neighbor zone. So neighbor zone connects expressway to another unified communication devices. It can be another expressway. It can be a CUCM. So where there is no firewall is there to interrupt. So when there is a firewall comes in, those becomes the traversal zones. Whereas neighbor zone is within your enterprise. It can be with any other device. It can be from one site to another also, but without having a firewall to interrupt the signaling and media. So in this example, we can see two sites with expressway C uh, connected together and a neighbor zone configured on these to one another. So here we can see expressway C servers that are neighbored, and the relationship means that a neighbor zone has been created on expressway A pointing to expressway B, and on expressway B pointing to expressway A. So endpoints that are registered to each of the two expressways now can communicate with each other with the signal routing through Cisco Expressway, but media flow directly between these devices.